and writing it with sort of different notation. Okay, but that's sort of basic algebra anyway. So number 60, 2x minus 2 is greater than or equal to 3 plus x. So in this case, I'm going to start by adding 2 to both sides. I'll end up with 2x is greater than or equal to 5 plus x. And as I'm doing this, because I'm thinking about what my next step is going to be, where I want to get, what are the sort of little cues there, what are the red flags, when I see greater than or equal to, I know that at some point I'm going to be drawing a bracket on the number line. I should know that at this point. Let's subtract x from both sides. I end up with x is greater than or equal to 5. There's my solution. X is greater than or equal to 5. I will graph it. I will locate 0. I will locate 5. I know I'm going in a positive direction. That is one ugly 5. Sorry about that. 5 is actually one of my favorite numbers, so I do apologize to the number 5. Much better. Okay. I'm going to put a bracket because 5 could be used for my solution, and my arrow will be going to positive infinity. Sounds like that movie Infinity and Beyond, but whatever it takes to remember it, okay? So now I want my interval notation. I would bracket it, place a 5. That tells me it could be 5. I am going to go to positive infinity and put a parenthesis, so I should be able to read that and know that my solution can be any number greater than 5 through infinity. Okay? Oh, we forgot interval notation. I'm sorry, set notation. Curly brackets, x such that x is greater than or equal to 5. Close curly bracket. And that's set notation. Interval notation, set notation. You work with it, you do 100 of them, you'll never have to memorize it, it'll just be part of who you are. Number 61. Hopefully you like red. All my other markers are dried out. That's what happens when you leave the cap off. So that's 60. Not surprisingly, 61 is next. Now 61 is going to bring some other skills that we've used in the past. Distributive property, nothing too difficult, so just don't let it intimidate you. So there's number 61. The problem that is presented is minus 2. In parentheses, x plus 3 is less than 8. All right, well, what are we going to do here? Well, let's just do a little distribution here. And we end up with a minus 2x minus 6 is less than 8. So at this point, I want to get rid of that minus 6 by adding 6 to both sides. I end up with a minus 2x is less than, let's see, what's 8 plus 6? Hopefully it's 14. So we have a minus 2x is less than 14. But we don't like a minus x. So I'm going to divide both sides by negative 2. Here's my little cue there. When I divide or multiply by a negative number, in this situation, I have to flip the inequality. So when I drop down here and do my math, that less than has to become greater than. So we end up with x is greater than negative 7. And that is our solution. At any point, and I'm not going to plug in the answers, but at any point if you don't feel confident with your answer, just plug it in, fill it in with x. You can do that on your own at this point. So now we have x is greater than negative 7. We will graph that. I'll locate 0. I'll locate negative 7. It's going to be greater than -7, which means we'll be going in a positive direction on the number line toward positive infinity. Because it's not equal to, which is greater than, we'll have a parenthesis, we'll have an arrow going positive infinity. Interval notation, parenthesis, get it up there, we pull it down here, -7, comma, infinity, parenthesis. So again, I've said this probably too many times, but your number line, your graph of the solution should help you write your interval notation. And then the set notation on this one, curly brackets, x, such that x is greater than -7, close curly bracket. And I think we're going to do one more. We'll do number 62, and hopefully I will have covered all the types of problems that will be presented to you in this homework assignment. So number 62, similar to number 61, we have -3, in parentheses, 1 minus x is less than 12. All right, again, we'll evaluate it. What should we do first? Well, I'm going to suggest that we do a little distribution here. That gives us -3 times 1 is -3. -3 times -x is a positive 3x is less than 12. I'm going to get rid of this 3 by adding 3 to this side, and of course I need to add 3 to the other side. I end up with 3x is less than 15. I want this 3x to become x. Of course I do. Divide both sides by 3. We end up with x is less than 5. We take x is less than 5. We graph it. We draw our number line. We throw in a couple of arrows. We'll locate 0. We'll locate 5. We want x less than 5, so I know I'm going to be going in a negative direction on the number line. It's not equal to 5, so therefore I have a parenthesis, and I know I'm going off into infinity. Interval notation, I will have negative infinity first, comma, 5, parenthesis. So if you look at this number line, we know we're going this way, negative infinity. We always use a parenthesis because there's no end. We know it's less than 5, so we have to have a parenthesis there. When we read this, we should know that our solution falls anywhere from any number less than 5 to infinity in a negative direction. And last but not least, our set notation, curly brackets, x such that x is less than 5, close curly brackets, done. 2 minus x, close parenthesis, is less than or equal to -2x. Less than or equal to a -2x. Okay, so what we can do here, let's see if we're going to be able to see that. Yeah, I think you got it. Is let's move this 8. Let's subtract 8 from both sides. And we will have a -4. Parentheses 2 minus x greater than or less than or equal to -2x minus 8. Let's distribute. -4 times 2 will give you a -8. -4 times -x, we have a negative times a negative, which is a positive 4x equals -2x minus 8. Let's move the -2x to the other side by adding 2x to both sides. That gives us a -8 plus 6x is less than or equal to -8. Let's take this -8 here, add an 8 there, add an 8 there. We end up with 6x is less than or equal to 0. We'll divide both sides by 6, And we will end up with x is less than or equal to 0. X is less than or equal to 0. We want to graph that. X is less than or equal to 0. We draw a number line. I'll start with 0. Less than or equal to will be going in the direction of negative infinity. And equal to will be our bracket. There is our number line graph. Interval notation, parenthesis, because we have negative infinity. That's an ugly infinity. Not my strongest letter. Negative infinity, comma, 0, bracket. Okay? I am not doing set notation because at this point, hopefully you understand set notation, just trying to move forward a little faster. Again, and we are on number 66. So let's see what we can do with number 66. Let's start with my marker, which I always lose. I should probably attach it somehow, surgically implant it into the tip of my finger. Painful, but well worth it. Number 66, we are asked to solve an inequality that is stating 3x plus 4 is greater than 1/3 times x minus 2. Okay, so I think what I'll do is distribute the 1/3. That's what I would like to do, make my life easier. And I will end up with x over 3 minus 2/3. I'm going to ultimately multiply that times 3 to get rid of the denominator. I have 3x plus 4, which I will also multiply times 3, because I'm doing it to the right side. I must do it to the left. 3 times 3x is 9x. 3 times 4 is a plus 12. It's still greater than. 3's cancel. We have x minus 2. I want to get the x on the right side over to the left side. I will do that by subtracting x from both sides. That will give me 8x plus 12 is greater than a minus 2. I will then take this 12, subtract 12 from the right side, subtract 12 from the left side, left and right. I end up with 8x is greater than minus 14. I will then divide by 8, both sides. It will allow me to state that x is greater than a minus 14 over 8, which is the same as x being greater than minus 7 over 4. So x is greater than minus 7 over 4. Let me move something here. I need a little more room here, guys and ladies. Yeah, that's where I need to be able to stand. So we have x is greater than negative 7 over 4. Let's see what that looks like on the graph. X is greater than minus 7 over 4. We draw our number line. We'll go with a 0 here. And 7/4, negative 7/4 is around 2. So we'll just put it right about there. And we're looking for greater than, so we are heading in a positive direction into infinity. So we are greater than, but we are not equal to negative 7/4, so we have a parentheses. And when we write that in interval notation, we start with a parenthesis. We write minus 7 over 4, comma, infinity, parenthesis. Okay? And that would be an interval notation. That is number 66. Off to 67. 67 is saying, just make sure I have it right here, x over 2 is greater than or equal to 1 minus x over 4. Okay, I have a couple of fractions that I would like to get rid of. I think I will multiply both sides by 4 to get started. That will allow me to cancel the 4's there, and this will become 1 minus x. On this side, I will be able to cancel that 2, and that will become a 2x. I will have 2x is greater than or equal to 1, sorry, I forgot to multiply the 4 times the 1, 4 minus x. At this point, I will get this minus x to the left side of the equation by adding x to both sides of the equation, resulting in 3x is greater than or equal to 4. Dividing both sides by 3, we end up with x is greater than or equal to 4/3. X is greater than or equal to 4/3. X is greater than or equal to 4/3. To graph that, we will draw our number line. I will start with 0. 4/3 is 1 1/3, a little more than 1, so we'll locate 4/3 there. Greater than or equal to, so I know I will need a bracket, and I will be heading off into infinity in a positive direction. Okay? This should, at this point, be pretty repetitive. Writing this in interval notation, I will start with a bracket. I will place 4/3, comma, infinity, parenthesis. And that would be the solution for number 67. 68. Let's see what we have for 68. Let's see what kind of job I did on 68. I think some of us may have had a little problem with 68, but we'll clear up all those problems. So 68 is asking us to solve the following. X over 3 is greater than or equal to 2 plus x over 6. I want to get rid of that 6 in the denominator. I want to get rid of that 3 in the denominator. I will multiply both sides by 6. That will nicely allow me to cancel the 6's. This will be written and read as 2 plus x. On the left-hand side, the 3 will cancel, leaving a 2x. 2x is greater than or equal to 2 plus x. I'll move the x from the right side to the left side by subtracting x from both sides, leaving me with x is greater than or equal to 2. 12. Why do I always do that? 6 times 2. See, when I'm in a rush, I forget to do the basics. And I think sometimes when we run into problems, it's because of the simple things. We go back over it. When I multiplied both sides times 6, I just dropped the 2 down, did drop the 12. So the answer that I'm looking for is x is greater than or equal to 12. Okay? Even the best of us make a mistake occasionally. So x is greater than or equal to 12. We'll rewrite it here. X is greater than or equal to 12. When we graph that, number line, here's my 0. We'll call that 12. We know it is equal. We know it's greater than. We know it's going in a positive direction, often to infinity. We will write that as bracket 12, comma, infinity, parenthesis. That is number 68. Number 69. Helps if you can write the number, Tom. Getting to that point in the day. Number 69. Okay. Number 69. Let's talk about that for a second. It's different than the other problems we've seen up to this point. If prior to doing number 69 and problems like that, I would suggest that you turn to page 124 look at example 9, and they are discussing solving combined inequalities. They give you a couple of nice examples, as does example 10. It's really rather simple, but it's not simple if you haven't done it. So let's do it. So what we have here for number 69 is 0 is less than or equal to 2x minus 6, which is less than or equal to 4. All right, simply put, we break this up into two separate equations. We take the 0 is less than or equal to 2x minus 6. We solve for that. Once we're done solving for that, we take 2x minus 6 is less than or equal to 4, and then we solve for that. And then we should end up with our solutions. So let's start with the left side. 0 is less than or equal to 2x minus 6. Okay, how do we do this? We're going to keep the x on the right side. I'm going to add 6 to both sides. I end up with 6 is less than or equal to 2x. I'm going to divide both sides by 2, ending up with 3 is less than or equal to x. And we're going to leave that just like that. Okay? Now we're going to come over here. I'm going to leave that solution there, just so I don't have to memorize it. And I'm going to work the right side of the equation, which is asking us to solve 2x minus 6 is less than or equal to 4. I'm going to move the minus 6 to the right-hand side of the equation by adding 6 to both sides. Okay? I end up with 2x is less than or equal to 10. I will divide both sides by 2, leaving me with x is less than or equal to 5. So now we have two solutions there, which states that 3 is less than or equal to x, and x is less than or equal to 5. When we draw that on the number line, we draw our number line. I will locate 0. I will look for 3. I will look for 5. X is less than, 3 is less than or equal to x. X is less than or equal to 5. There you go. It would, any number between 3 and 5, including 3 and 5, would work for our solution. Okay? When we put that in interval notation, using our graph, our number line as our guide, bracket 3, 5, bracket. That is number 69. So the key, again, if you go back, you look to page 124, example 9 is a good one. Solving combined inequalities. You break your problem up into two separate sections. Okay? So hopefully that will help us with the remaining problems. That would be number 69. As we move our way toward, I think 75 is how far we went. So there's number 70. All right, let's find number 70.